All right. Okay, so I'm going to take a minute here and run through this iceboat problem, all right? And so what we've got, they give you this position time graph. So what the position time graph does is by reading the graph, it enables us to figure out the position of the iceboat at, specific times. The problem is we don't know the velocity of the boat at any time, really, right? So, I mean, I guess you could try to draw in tangent lines and measure it that way, but that would be an estimation at best, all right? So what we're trying to do, though, is for part A, we're trying to figure out what is the acceleration of the boat. Worth noting that it is constant, which means we can use those linear motion equations from last year. Part B wants us to find the velocity at a time of 3 seconds. And part C wants us to figure out what is the displacement from 3 to 6 seconds. All right, so those are the three questions. All right. So if we look at this graph, the idea is we're going to have to pick some sort of time interval, right? Because any kind of equation we have deals with a time interval that begins here and ends here or whatever. So let's think about our linear motion equations. All right. So what do we got? Well, so there's acceleration equals VF minus VI over t. This one doesn't help us at all because no matter what time interval I pick, there are going to be three unknowns, right? I don't know my acceleration, I don't know the final velocity or the initial velocity. So this guy's not going to be probably of much help, all right? What about this guy? Oops. Oh my gosh, stupid tablet thing. Okay, so what about this guy? All right, so now if I choose some time interval from my graph, let's see, if I pick a time interval, I can figure out what for example, what my starting and ending positions are, right? So that means that I can find my displacement. I can find my time, certainly. So here I have two unknowns, right? I don't know the acceleration of the boat, and I don't know the starting velocity, okay? So since I have two unknowns, I got to pick two equations, right? So let's try a different equation. So what if I try using this guy? All right, well, let's see. Now, the problem here is not only do we have the same two unknowns, we still don't know our acceleration or our VI, we've also got this VF. So now there's a third unknown, which would then mean a third equation, right? So I guess if you really wanted to, I wonder if this would even work. I don't think that it would. So I guess the third option would be then, okay, well, now we've got three unknowns, let's pick three equations. So I don't know if this will work. I'm worried that it's going to give you a trivial answer, like 0 equals 0 or something like that. But we do have the same three unknowns, right? You don't know, or you've only got two knowns, VF and VI. So you might be able to do it that way, but I really think it's going to give you a, like I say, 0 equals 0 if you try to solve it. All right. So what do we do? So this is a really, really good trick for graphs like this. So notice we've got a lot of information, and there's nothing magic about these two orange points that I picked here and here, right? So instead of choosing two different linear motion equations, we're going to pick one linear motion equation, but we're going to use it for two different time intervals, okay? So let's think about this. So suppose I consider for a minute, the first 1 second of motion. Okay, so if I do that, let's see. So if I consider the first second, then what do I know? Well, let's see. For that first second, I know that 1 second elapses. I know my displacement because I can just read it off the graph, right? My position's going from 0 to 7. So my displacement is 7 meters. I don't know what my acceleration is, and I don't know either my initial or final velocity, but if I use this equation here, I don't need my final velocity. Okay? And now if I repeat that same process, but I choose a different time interval, so suppose I go for the first 2 seconds. First 2 seconds. What do I know for that time interval? Well, I know the time is, I don't like how skinny that pen is, let me fix that. So I know the time is 2 seconds now. I've got a new displacement, right? Now my displacement is I'm going from a position of 0 to a position of 16, if you read that graph. I don't know my acceleration, but I do know that these two are the same acceleration, right? And I don't know my initial velocity, but once again, these two accelerations, or these two initial velocities are the same, right? Because both of my time intervals begin right here. All right, so now what I've got is two different time intervals with the same two unknowns. I'm looking at the wrong camera. With the same two unknowns. We don't know the acceleration or the initial velocity of those two time intervals. So now what I'm going to do is I'm going to use this equation here and plug in my numbers, okay? So for the blue one, I'm going to get displacement equals 1/2 a times t squared plus vi times t. And for the green time interval, I'm going to get 16 equals 1/2 a times 2 squared plus vi times 2. Aha, and now I have two equations and two unknowns, and so I can solve it. All right, this is a very, very common problem solving technique in physics where you write two equations and two unknowns, okay? On the last worksheet, we had that the problem with the car and the truck, right? And I did the same thing. I wrote out an equation for the position of the car at time t, and an equation for the position of the truck at time t. Did I say that right? One's for the car, one's for the truck, and set them equal to each other, right? So same idea here, okay? We're using the same equation twice for two different inputs, in this case, two different time intervals. Okay, so let's go through and solve this thing. So let's see. So if I simplify this green equation, I'm going to multiply both sides by 2 to get rid of this 1/2 here. So this green equation, or the blue equation, wow, I'm struggling today. This blue equation here becomes 14 equals a plus 2vi. All right, and the green equation becomes 16 equals 2a also plus 2vi. Oh, that's cool. All right, so now we got to solve this thing. So there's a bunch of ways you can do this, right? You guys have learned in math class how to solve a system of equations. Probably the beginner way to do it would be to solve this first equation for a and then plug it into the other one. I'm going to actually just subtract these two equations, right? So let's see if I subtract these, then 2v minus 2v gives me 0. A minus 2a gives me negative 1a. And 14 minus 16 gives me negative 2. Aha! My acceleration is 2 meters per second squared. All right, so now I can plug that back into one of these equations and find it. So let's see, 14 equals a. So 2 plus 2vi, 12 equals 2vi, vi equals 6 meters a second. All right, so this was, let's see, what were the three questions we had to find? So question A wanted us to find the acceleration. We just did that. So here's the acceleration. Question B wants the velocity after 3 seconds. Well, Vf equals Vi plus At. So the velocity after 3 seconds is Vi, 6, plus acceleration, which is 2, times the time. So you get 12 meters a second. And then finally, to find the displacement during the second 3 seconds, I'm going to do that one over here in purple. So what do we know? So from 3 to 6 seconds, we know our initial velocity is 12 meters a second. We know the time elapsed is 3 seconds. We know our acceleration is 2 meters per second squared. I think we can just use this guy, 1/2 at squared plus vit, and plug in your numbers. And that should give you the answer, which I don't remember off the top of my head, but you guys can certainly plug and chug. All right, cool. Hope that made sense. If not, I will see you in class or office hours or whatever. Stop recording. Wow, terrible lighting. Ooh, that's much better. I don't look like I'm in a cave anymore.